This is Bob Capetta, and this lesson is on combinations. So our first example, a pizzeria offers 5 different ingredients: sausage, pepperoni, mushrooms, olives, and anchovies. How many pizzas with exactly 2 ingredients can be made? So not more than 2, not fewer than 2, exactly 2 ingredients. We're going to list all of those ingredients. So the first ingredient I have listed is sausage and then pepperoni. So we'll put sausage and pepperoni together. Then sausage and mushroom, sausage and olives, sausage and anchovies. So those are all of the possibilities that have sausage. I've exhausted sausage. Next up is pepperoni. So pepperoni and sausage has been used. Order doesn't matter here. The ingredient you say first or the ingredient you say second doesn't make a difference. So sausage pepperoni is the same as pepperoni sausage. So in this example, pepperoni sausage is not a different pizza, it's the same one. So our next different pizza would be pepperoni mushroom, then pepperoni olives, and pepperoni anchovies. Now we've used pepperoni on 4 different pizzas, that's all we're going to have. Now we're looking at mushrooms, mushrooms and olives, mushrooms and anchovies. We've used mushrooms now on 4 different pizzas, and finally olives and anchovies. So we have been able to make 4, 5, 6, 7, 8, 9, 10 different pizzas with exactly 2 ingredients. Order in which we choose them does not matter. So there's our conclusion. 10 pizzas can be made by choosing 2 ingredients from a possible set of 5. Now, this is a combination. The notation that we use is 10C3 or 10 choose 3. So the combination of 10 with 3 is 5. Another notation that is often used is this parentheses with a 10 on top of a 3 with no fraction bar. That's another common notation for 10 choose 3. That's a combination, and that is used when order does not matter. So here's another example. This time a department at a college has 7 members and 3 must be chosen to attend a meeting with the dean. So you are either attending the meeting or you are not attending the meeting. So again, order doesn't matter. So we want to try to list all of those. I'm going to just give names to all 7 people: Al, Barb, Chuck, Deb, Ed, Frank, and George. A, B, C, D, E, F, G. And I'm going to try to list all of them. Now it's going to be a whole bunch. So we have 7 that we want to choose 3. I'm going to do my first list is Al and Barb. So Al, Barb, and Chuck, Al, Barb, and Deb, Al, Barb, and Ed, Al, Barb, and Frank, Al, Barb, and George. Those are all the possible Al, Barb groups. Now I'll go to the Al, Chuck groups, right? Al, Chuck, and Deb, Al, Chuck, and Ed, Al, Chuck, and Frank, Al, Chuck, and George. Those are all the Al, Chuck, Georges, Al, Chuck groups. Now how about Al, Deb? ADE, ADF, ADG. Those are all the Al, Deb groups. The Al, Ed groups, AEF, AEG, are all the Al, Ed groups. The Al, Frank groups, Al, Frank, George. That's it. So those are all the groups that have Al. So Al is shown in 10 possible different ways Al can be chosen. But now let's start with Barb. So my first group would be Barb, Chuck with Deb, then Barb, Chuck with Ed, etc. Okay. So BCD, BCE, BCF, BCG. Those are all the Barb, Chuck groups. How about the Barb, Deb groups? Barb, Deb, Ed, Barb, Deb, Frank. Barb, Deb, Frank, Barb, Deb, George. Then Barb, Ed, Frank, Barb, Ed, George, Barb, Frank, George. So those are all the groups that have Barb in them. Notice how many groups have Barb? 4, 5, 6, 7, 8, 9, 10. But we also have some over here, right? 11, 12, 13, 14, 15. We had 15 groups that had Barb in them. So we've exhausted all of the possibilities for Barb. Now starting with Chuck, Chuck, Deb, Ed, etc. CDF, CDG, CEF, CEG, CFG. And then starting with Deb, DEF, DEG, DFG, starting with Ed, EFG. That's all of them. That's a whole bunch. 15 plus 10 is 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. 35 total. So we had an original set of 7. We had to select 3 to participate in this meeting. 7 choose 3 is 35. Now, you'll recognize that counting or listing all the possibilities is a very challenging enterprise. So thankfully, we don't have to do that every time. We have some tools we can use instead. There's the other notation, 7 choose 3 is 35. So one of our tools is Pascal's triangle. Maybe you've seen this before. If not, let me show you how Pascal's triangle is developed. We start with a 1 on top and then a 1, 1 underneath. So always 1 on the left, always 1 on the right. And then you add the two numbers up on top. So 1 plus 1 is 2. That's how we get 2. 1 plus 2 is 3. 2 plus 1 is 3. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4 with 1 on the outside. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. 1 on the outside. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. So you can generate this to as many rows as you want, although yes, the numbers get very large very quickly. So you can see the way we have these rows numbered. Whatever the first non-1 row is the row number. So row 2 has a 2 in it, row 3 has a 3 in it, row 4 has a 4 in it, row 5 has a 5 in it. We want to focus on row 5. What is row 5 here? 1, 5, 10, 10, 5, 1. So that's row 5. But each one of these corresponds to combinations that start with a set of 5. This 1 is 5 choose 0. I have 5 items. How many have exactly 0? Well, only 1. 1 with nothing. 5 items. How many have exactly 1? 5 possibilities. So an example here would be if you have 5 pizza ingredients, how many pizzas have exactly 1? Well, 5. Only sausage, only pepperoni, only mushroom, etc. Have exactly 2 items, we've already seen that that's 10. Have exactly 3 items, also 10. Have exactly 4 items, 5, exactly all 5 items, that's a pizza with everything, there's just one possibility. So Pascal's triangle gives us all those numbers. 5 choose 0 is the first number, 5 choose 1 is the second, 5 choose 2 is the third number, 5 choose 3 is the fourth number. Well, we listed all of them and said 5 choose 3 was 10. Here from Pascal's triangle we see 5 choose 3 is 10. So that's a nice way for us to check our work. Now, is 7 choose 3 35? So let's go down to row 7. Row 7 has a 7 in it. 7 choose 0 is the first case. 7 choose 0 is 1. That's your cheese pizza, no ingredients. 7 choose 1, exactly 1 ingredient on the pizza. If you have 7 ingredients with exactly 1, there's 7 possible pizzas. 7 choose 2, 21. 7 choose 3, 35. That looks good. So that does seem to check what we had before. Just to clarify that, row 7 is 1, 7, 21, 35, 35, 21, 7, 1. 7 choose 0, first piece. 7 choose 1, 7 choose 2. 7 choose 3, 7 choose 4, 7 choose 5, 7 choose 6, 7 choose 7. So Pascal's triangle is a nice way to kind of visualize these combinations. And it can save you some time with computation. But we're going to want to have a rule that will enable us to do these, not unlike our rule that we had for permutations. This will also involve the factorial. So here's our rule. N choose r is n factorial over n minus r factorial times r factorial. So the first one we did was 5 choose 2, so n is 5, 5 factorial. 5 minus 2, r is 2, 5 minus 2 factorial, 2 factorial. So it's 5 factorial over 3 factorial, 2 factorial. 5 factorial is 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1. You'll notice the 3 2 1s and the 3 2 1s go away. And I get 5, 4, 20 upstairs, 2 downstairs, and I hope that's obvious that that's 10. So using our formula, we also get our answer of 10. How about 7 choose 3? Now n is 7, 7 factorial over 7 minus 3 factorial, 3 factorial. 7 minus 3 is 4. So we'll have 7 factorial over 4 factorial, 3 factorial. 7 factorial, 7, 6, 5, 4, 3, 2, 1. 4 factorial, 4, 3, 2, 1. 3 factorial, 3, 2, 1. Well, the 4, 3, 2, 1s will cancel, leaving 7, 6, 5 over 3, 2, 1. But 3, 2, 1 is just 6, so that would divide out. 7 times 5 is, of course, 35. Now, we can do this on Excel to save ourselves some work. So we've seen Pascal's triangle, we've seen listing them all, we've seen the formula. The Excel strategy is one other way to do these, and these numbers are going to get pretty large, so I do encourage you to make use of Excel. So if I want to use 5 choose 2, the Excel command is equals combin 5, 2. If I say 7 choose 3, the Excel command is equals combin 7, 3. So let's see, 5 choose 2, 7 choose 3. I'm going to go ahead, I'm going to pull that up if I can. So equals combin 5 choose 2. We hope it's going to give me 10. And it does. Similarly, equals combin 7 choose 3. Let me make this a little bit bigger. Oops. Equals combin 7 choose 3. What do we get? We get 35. So that matched what we expected it to be, and we're feeling good about that. All right, let's take a look at the difference now between permutations and combinations. So here we have a high school softball team has 18 players, and 10 must be chosen for a batting order. How many ways is this possible? Well, it's called a batting order, so you could have the same 10 players in a different order. That's a different batting order. So order certainly matters here. When order matters, it is a permutation that is necessary. So what I want is I want the permutation of 18 in the original set to arrange 10. 18 in the set, arranging 10. So n pick r is n factorial over n minus r factorial. So it'll be 18 factorial over 8 factorial, which is 18 times 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 divided by 8, 7, 6, 5, 4, 3, 2, 1. Well, you'll notice everything from 8 below divides out, and I just get this. Now that's going to be a hassle. 18, 17, 16, 15, 14, 13, 12, 11, 10, 9. How are we going to multiply all of those together? I'm going to suggest that you again use Excel. So we're going to start at 18, 17, 16, 15, 14, 13, 12, 11, 10, 9. We want to multiply all of those together. The command is equals product. And highlight everything there. And then we'll multiply those together, and what do we get? 1.58789e plus 11. What does that mean? What does that mean? Well, I've copied down the result from Excel here on my slide, but that is scientific notation, so that's about 1.59 times 10 to the 11th power. That's the exponent, scientific notation, 1.59 times 10 to the 11th power, so a very large number. Focus on the fact that order matters in a batting order. It matters. In the previous video on permutations, we selected a president, vice president, secretary, and treasurer. Order matters. Different jobs, different assignments. Order matters. In our next case, we have a bowling team with 14 players, and 8 must be chosen to attend a tournament. In how many ways is this possible? Whether you're the best player and selected first or the weakest player and selected last, it doesn't matter. You are still going to attend the tournament. So in this case, order does not matter. If order does not matter, we can use a combination. So let's first try this with our formula. So we have 14 players. We want to choose 8 to attend. 14C8. 14 factorial over 14 minus 8 factorial times 8 factorial. That's the difference. If you use a combination, you have this extra factor in the denominator. Well, 14 minus 8 is 6. So I get 14 factorial divided by 6 factorial, 8 factorial. Well, let's list all that out. 14 factorial, 14 all the way down to 1, 6 factorial, 8 factorial. Well, you notice the 8 factorial all divide out. 8, 7, 6, 5, 4, 3, 2, 1. 8, 7, 6, 5, 4, 3, 2, 1 would divide out. So now we get 14, 13, 12, 11, 10, 9, and 6, 5, 4, 3, 2, 1. And this may be another job for Excel to help us with the computation. So let's go back to Excel. Starting at 14, 13, 12, 11, 10, 9. I believe that's as far as we want it to go. It is. And then downstairs we have 6, 5, 4, 3, 2, 1. 6, 5, 4, 3, 2, 1. Let's take the product of the top. Equals product of all these numbers. and I get 2162160. So what is that? 2,162,160. Let's take the product of these numbers. And we get 720. So I have a fraction. This number is on top, that number is on the bottom. And we can also let Excel go ahead and reduce that fraction for us. Just divide those out. So we'll say equals this number divided by this number. And what do we get? We get 3003. So it looks as if the number of ways we could select for our bowling team members to attend the tournament, 3003 different combinations, different groups of students we could choose to attend that tournament. Now we could have gotten that 3003 directly if we use the Excel command equals combin. So again, this is 14 choose 8. Let's just check it quickly with that. So equals combin 14, 8. We hope we get 3003, do we? We do. That checks our work, and that will complete this lesson.